Now, this will be the third revision session. I have already given you revision on circular measures and trigonometry. I think there were 2 videos. Now it would be the 4th video or session number 3 on further differentiation. Differentiation has been already covered in our school session, which I gave it to you, revision session on Thursday. But now this is our last chapter, further differentiation. I'm going to record it for you. So are you ready? So inshallah, I'm going to share my screen with you now. Yes. So here you can see the further differentiation, not very difficult. So let's start with it. The first type of question, which I put it over here, find the range of values of x for which the y is increasing. Yani function increasing and decreasing. Let me explain it to you. Suppose this is my x-axis. Okay, and I'm going to draw any curve like this. This is the equation of a curve. Now, as you can see, the stationary points or minimum or maximum points at these points. This is my stationary point. This is stationary point. Why stationary point? Because here the graph changes its trend. Okay, now your x-axis is divided by these stationary points. In this way. How? You can see your graph is increasing from minus infinity to this value. So the function is increasing. Function is showing an increasing behavior when x is less than a. And then after that, you can see your function is decreasing between a and b. The function is decreasing between a and b. And then again, you see your function starts increasing after b. So x greater than b, function is showing an increasing behavior. This is the application of differentiation that without sketching, you can tell that when the function is increasing. So the increasing nature tells you that dy by dx is positive, greater than 0. And the decreasing nature tells you when the dy by dx is negative. Same thing here. Right? Examiner will ask you find the values or find the range of on the x-axis or range of values of x for which the function is increasing or decreasing. How will you do this? You will take the derivative and then you put greater than 0 your derivative if he says find the range where the function is increasing. And then otherwise, if he says find the values of x where which the function is decreasing, then you put derivative less than 0. Right, boys? So we are ready to start our questions. Allow me to erase this because this is just for the explanation purposes. I have done it here. So now I'm going to start with the very first question. This is a part. Y is equals to 5x squared plus 5x. I need to take the derivative dy by dx 10x plus 5. Your function, I want to check the increasing nature of the function. So put derivative greater than 0. So 10x plus 5 greater than 0, 10x greater than minus 5, and x greater than minus 5 over 10. Or in other words, in the exam, you do it like this, that Mr. Omer, if x is bigger than minus 1 over 2, our function will be increasing. Clear? Let's do the B part. In the B part, he gave you, again, a quadratic function. So let me take the derivative first. Derivative of 3 is 0. 16x is 16. Minus 8x. Again, he's asking you increasing function, put greater than 0. Send the minus 8x to the right. So as long as your x is less than 2, your function is increasing. If you want to see it, you can draw this sketch or graph on the graphical software. See y is equals to x cubed minus 3x minus 4. To find the increasing nature, take the derivative 3x squared minus 3, right guys, and greater than 0. This looks like a quadratic equation. I think it's better. You should write it in this form. How? 3x squared plus 0x minus 3 greater than 0. In your calculator, there is a feature which helps you to solve the quadratic inequalities. Or you already know it is these are the two values in which we are going to get the fountain like of situation. In a moment, I will show you. Look, first one is going to give you greater than 0. So enter 3, enter 0, enter negative 3. I got x less than minus 1 or x is greater than 1. So these are the two values or the range on the x-axis, which tells you if you pick the values of x here, it will give you derivative positive or the function shows an increasing behavior. So question number 1 is done. Next question in which I'm asking you find the range of values of x for which the function is decreasing. Decreasing means your dy by dx should be less than 0. Even though if you write dy by dx less than 0 in the exam, you will get 1 mark from me because you know that decreasing tells you derivative of function is always less than 0. Now, instead of f of x, it is instead of y, now he is writing f of x. So the derivative of f is f prime. And 9x squared, 18x, and this is minus 6x squared. I'm looking for decreasing function, put it less than 0, right? So let me copy minus 6x squared plus 0x, sorry, not 0x, plus 18x plus 0 less than 0. Now I need to use my calculator. Let us go back to the inequalities. Which inequality I'm looking for? What happened? Degree 2, yeah, that's fine. Degree 2 polynomial, and I'm looking for minus 6 less than 0 situation. It is option 2, minus 6, enter. 18, enter. 0, enter. Calculator tells you x less than 0 and x less than 0 and x is greater than 3. So these are the two ranges on the x-axis which tell you where the function is decreasing. Next question. F prime 0 minus 5 minus 20x. Put it less than 0 because I'm looking for decreasing functions. Minus 5. Send the minus 20x to the right. So 20x minus 5. So minus 1 over 4. So if your x is bigger than minus 1 over 4, your function will be decreasing. Dash of x, 3x squared plus 12x plus 12 less than 0. Solve the inequality. Less than 0. Option 2. 3, enter. 12, enter. And 12, enter. No solution. Why no solution? Because when I draw this graph, it is totally increasing. I'm just showing it to you how it will look like. It will look like this. So look, it is totally increasing. That's why there's no decreasing behavior. So no solution. There's no value of x for which the derivative is negative. So no solution. Now we go to the question number 3, where he talks about stationary points. And we need to talk about the nature of the stationary points. As I drew in the previous part, these turning points are our stationary points, because if we draw the tangents on stationary points, the tangents will be parallel to x-axis and the dy by dx gradient is 0. So we need to find dy by dx whenever he says stationary point, turning point, and then we will take the second derivatives to check the nature of these functions. So first question, f of x is equals to 2x cubed minus 3x squared. First derivative, 6x squared minus 6x. Put it equals to 0. You can solve it with the help of calculator. Six minus 6 and 0. So 1 and 0. So we got x is equals to 1 and x is equals to 0. We want to find the y coordinates as well. And you substitute these values one by one into the original function to get the corresponding values of y. So find f of 1 or y. So this gives you y is equals to minus 1. So first point is 1 comma minus 1. Substitute 0. 0, 0. So these are the two stationary points we found, but at this moment I am not sure at these 2 points I am getting a maximum point or minimum point. For this reason, I have to find the second derivative from here. This is my first derivative. I found it. I'm trying to find my second derivative, which is f double dash of x. I will try to find f double dash of x of this thing. Will give me 12x minus 6. Now substitute the values of x one by one if I put 1 and if I put 0. So f double
6
dash
and
of
0.
1 is equals to 12, 1 minus 6. 12 minus 6 will give us 6. And this is a positive answer. It means this point is a minimum
point.
Right? I think Abdullah is here. Assalamu alaikum, Abdullah.
Alaikum salam.
So f double dash of 0, 12, 0 minus 6 into the second derivative I substituted. I got 0 minus 6. Since my answer is negative, so it means I'm going to get a maximum point. So which point is minimum? 1 minus 1 is minimum, and maximum point is 0, 0. So that was the first question in which he was asking stationary point and determine their natures. Let us do the B part now. This B part. F of x, 2x cubed.
Assalamu alaikum.
Wa alaikum salam. 12x plus 4. You get the first derivative to find the stationary point. So 6x squared minus 18x plus 12. So once you find the derivative to get the stationary points, we put the first derivative equal to 0. So we open our calculators. Now this
Then,
one.
then we solve it as quadratic.
Oh, as quadratic. Yes, absolutely right.
Allah, Allah, Aleen.
So enter 6.
Yeah, boy.
Enter minus 18. Enter 12. We get the two answers, 2 and minus 1. X is equals to 2. X is equal to 1. Since the examiner says we need to find the coordinates of stationary point, we
Then
need
put
to
the original equation, plug x.
Yes, so we will substitute the values of x into the original function. So 2 power 3 minus 9, 2 squared plus 12, 2 plus 4. And I will also substitute 1. Now we will use our calculators. So 2 bracket open, 2 power 3 minus 9, 2 bracket close squared plus 12, 2 plus 4, and it gives us 8. Now try to find the second coordinate as well. In the place of now 2, I will replace by 1. And it gives us 9. So I got 2 points. First point is 2, 8, and second point is 1, 9. And I need to check these 2 points. Are these points at maximum point or minimum point? For this, I will focus on my first derivative, which I found it here. I'll try to find its second derivative. So second derivative, I'll use a different color, f double dash of x, or f double prime. So it will be 12x minus 18. Now in this second derivative, one by one, I will substitute the values of x. So first I will substitute this 2 into the double derivative of double dash of 2. What is that? 12, 2 minus 18. It gives you 6, which is a positive number. So it means 2, 8 is my minimum point. Now I substitute 1 into the second derivative. F double dash in the place of x, I will substitute 1. So 12 minus 18 minus 6, which is negative. It means 1, 9 is my maximum point. So guys, as you see that I have done with A part and B part. Now let's move on to the C part, x plus 1 over x. C part, f of x plus 1 over x. First of all, we need to rewrite it and send the x on the top. So x is for -1.
Yusuf,
Yes.
if after you do the second derivative, you substitute x, the answer is positive. This is minimum point.
Minimum point. Yes.
Thank you.
So now we take the first derivative, it gives 1, and -1 goes back. -1. So f dash of x, 1 minus x raised to -2. We need to put it equals to 0 to get the stationary points. I can write it like this. Then I send it to the right-hand side. Then cross multiply. Then take square roots. And I got x is equals to 1 and x is equals to -1. These are the x coordinates. And I need to find the y coordinates as well. For this, I need to plug it into the original function. So y is equals to 1 plus 1 over 1, or y is equals to 1 plus 1. It gives you y is equals to 2. So what is the point I got? I got 1 and 2. Then I substitute -1. So y is equals to -1. It gives me -2. So second point is -1 and -2. Now we need to look at these 2 points. Are they maximum or minimum points? For this reason, I need to get the second derivative. So this was the first derivative I found. Now I'm going to find my second derivative. The derivative of 1 is 0, minus the -2 goes back, -2 minus 1. This becomes 2 minus 3, or I can write it as 2 over x power 3. Now one by one, I will substitute the values of x. The value of x was 1 and x value was -1. Substitute it. What is my f double dash? F double dash of 1 is equal to 2 over 1 power 3, which is 2. This is positive. So it tells you that 1, 2 is a minimum point. Okay, so this is your minimum point. Now I substitute f of x is equal to -1 into the f double dash. F double dash of -1 is 2 over -1 whole power 3. So 2 over -1, and this is -2, which is a negative value. So it tells you that -1 and -2 is a maximum point. So I found the maximum point. Last question here on stationary point is f of x is equals
Mr.
to.
Omar?
Yes.
Yes, we have. I'm sorry, I cut your word.
No problem. Please tell me.
Mr. Omar, I want to tell you, we have to know the all value of volumes equation, because I saw in the revision pack many questions on volume.
The volume of a sphere you need to know, which is 4 over 3 pi r cubed, and surface
R
area
cube.
pi r cube, and surface area 4 pi r square. I also added these formulas in MF19, so you can consult MF19, and otherwise if you can memorize it as far as the importance of the question is concerned, yes, volume is very important for rates of change. Okay,
Okay,
Ahmed?
thank you, sir.
And Mr. Omar,
Yes. Yes, Abdullah?
when will we have mechanics revision?
Tomorrow, inshallah.
Inshallah.
So f of x is equals to, guys, I'm going to split it. First, x squared over 2x plus 9 over 2x. So f of x is equals to, I'm going to cancel x with x squared, so it becomes x over 2. And this is 9 over 2. Can I send the x on the top? So now the question is ready to be differentiated. So f dash of x, it is 1 over 2. 9 over 2 minus 1 goes back. And from -1 is -2. I'm going to put it equal to 0. Half minus 9 over 2. 9 over 2. And I'm going to bring x squared down is equal to 0. Since it is negative, I'm going to send it to the right. So half is equal to 9 over 2x squared, do the cross multiplication. So 2x squared is equals to 18. X squared is equals to 18 divided by 2, 9. And then x is equals to plus minus 3. So I got x is equals to 3 and x is equals to -3. So once you got the two values of x, now you want to find the corresponding values of y. We will substitute them into the original equation. So original equation is f of 3. I'm going to plug it. 3 squared plus 9 over 2, 3. So 9 plus 9 is 18. 18 over 6, and that gives me 3. So f of 3 is 3. What is the point? 3 comma 3. Next, f of -3. I'm going to plug, since it is a negative number, keep it in the brackets. -3 whole squared plus 9 over 2 minus 3. 9 plus 9 over -6, 18 over -6, and I got -3. F of -3 is -3. So my second point is -3 and -3. Now I need to check both of these points are maximum or minimum. For this, I want to focus at my first derivative. Where did I find it? I found my first derivative here. I'm going to take a second derivative of this. First derivative and now second derivative. The derivative of half is 0. Minus 9 over 2 will come as it is. Minus 2 goes back, and from -2 I subtracted 1. This is my second derivative. 2 cancelled, and I'm getting 9. X is from -3 is f double dash of x. Write it in a beautiful form. F double dash of x is equal to 9 over x power 3. Now step by step, substitute your two values of x, 3 and -3, into the second derivative. I'm going to plug. First of all, x is equals to 3. So f double dash of 3 is 9 over 3 raised to power 3, which gives you 1 over 3. It's a positive number, so it means 3 is my minimum point. And I want to check also my x is equals to, just wait, boys, there is a glitch. I wish it works now.
Yes, Mr. It's working. I can see the one.
Okay. So x is equals to now -3. I will substitute. Thank you, Ahmed. F double dash of -3 is equal to 9 over, in the bracket because it's a negative number. So I'm going to get -1 over 3, which is a negative answer. So it tells you that your -3, the point which you have found earlier. Now this point qualifies as a maximum point of the curve. Alhamdulillah, the stationary point concepts. This is your answering key, boys. And you can, if you want to refer it to the answering key, this is the answering key. Question number 3 is done. Now let's move on to the question number 4. You can see
now,
now. Yeah,
Mr. There is the rates, right?
yeah. No, I think this is again application part. Let's read. The guy said a cylinder. So guys, you can refer it to MF19. Cylinder is like this, and cylinder has two things. Has a volume. So since its base is a circle, so the area times height, any volume is equals to pi r squared h. I don't know what examiner is thinking about. Examiner says that there is a cylinder with open top. Open top means there is nothing here. This is open. So it looks like he will talk about surface area. Let's see what happens. He said that the volume is this. Wow. If the guy says volume is this, I need to write the volume of a cylinder. So the volume of a cylinder is pi r square h. And he said volume is 512 pi is equals to pi, and this will help us, boys, to get the relationship between R and H. And in the first part, examiner will ask you to make H as a subject or R as a subject. But if you see, he didn't say anything about R and H. He said directly surface area. So after finding this relationship, my friends, keep it on the side and now write another formula which is called surface area formula. I will use A for the surface area. Now it has three parts. You remember bottom plus top plus the curved part. Okay, I need to find the area of everything. Bottom is a circle. It is pi r square. Since he said open top, so it means there is mafi top module, so no need to add it. No need to add it. So bottom is done. What is the curved part? In the curved part, you remember in IGCSE, I told you, you need to find the circumference. The circumference is 2 pi r multiply with h. Wallahi, that will give you the curved surface area. So the curved surface area formula is 2 pi r, the circumference, 2 pi r circumference times height. This is not given in MF19, the surface area formula. But be careful, the examiner used open top. When he says open top, so it means we cannot take the top. So pi r square will not be furthermore included. Only pi r square plus 2 pi r h, and that is equals to the area. We need to write, according to the examiner, write the surface area in terms of R. You can check it out, the area which I wrote it here, it is not in terms of R square, it is in terms of R and H. How can I get rid of this H? Do I have any relationship which can convert H into R square into R form? The answer is yes, Mr. Omar. From the volume, you can easily make H as a subject. So your H will become equal to what? 500 and come on, 512 over R square. Can I plug it here? Okay, now area is equals to pi r squared plus 2 pi r. In the place of h, I'm going to write 512 over r squared. Wow. Now area is converted only into r form. Can I cancel r with this one? And 512 times 2 is 1082, or I think 1024. So 1024 pi over R. Wow. Now area is given in terms of R. That was the first question. Write down the surface area of cylinder in terms of R. We wrote it. Now the next thing is he's going to ask you find the maximum or minimum value of A, and you need to take the derivative and put it equals to 0. Did he talk about this? Find the minimum surface area. Take the
Mr. Omar,
derivative. Yes.
I'm sorry, just I will leave for 10, 15 minutes and come back.
No, no worries, no worries.
Thank you.
1024 pi r is per minus 1. So when the r goes up, its power will be minus 1. Now I'm going to take dA over dr. So this is 2 pi r plus 1024 pi as it is. And the minus 1 goes back, and minus 1 is minus 2. So this is my dA over dr. I need to put it equals to 0 as per the rule. So 2 pi r minus 1024 pi over r squared is equal to 0. Now send it to the right hand side. 2 pi r is equals to 1024 pi over r squared. Boys, cancel pi with the pi. Do the cross multiplication. So 2r cubed is equals to 1024, right? Now send the 2 to the other side. 1024 divided by 2. What is the answer I got? 1024 divided by 2. It gives me 512. So 512. Take the cube root of 512. What the answer comes to you? Cube root of 512 is 8. Wow. So the radius is 8. Now I found the radius. Did he ask us? Find the minimum surface area in terms of pi. He didn't say find r. Now this r should be substituted into the area formula to get our minimum area. So where is the area formula? This is the area formula. So substitute it into this. So when I do this, A is equals to pi times 8 square plus 1024 pi over 8. So this becomes 64 pi. Let me simplify. 1024 divided by 8 gives you 128 pi. Can I add 64 plus 128 will give me 192 pi square units. That is the area which we wanted to find. This is the minimum area we want to get. Now the guy said, calculate, find the value of R. Yes, we found the value of R and the height of the cylinder. Height of the cylinder can be found by substituting here. H is equals to 512 over radius was found 8 squared. So I'm going to write 512 over 8 square. It gives me 8. So height is also 8 centimeters or whatever the units he has used. So we found height. I need to write here centimeters squared. This is the area. So let me give you the reflection of this question. He talks about a cylinder. In cylinder, he gave you the volume. I wrote a volume formula, and it helped you to create a relationship between it gave you the it helped you to find the relationship between R and H. Then I make H as a subject. That H was substituted here when I wrote the area formula, surface area formula. But the important point was this cylinder was not having the top. It was not having the lid on the top. In such a case, when I take a surface area, I need to just include bottom, which is in a circle form. So I wrote pi r squared, and then I have to take the curvy part, which is 2 pi rh, and then h was replaced by 512 over r squared, because in the first part that he said find the area of the surface area of the cylinder, open cylinder, in terms of r. I wrote it. Then he talks about the maximum minimum value of A. We got the derivative and put the derivative equal to 0. It gave us the radius, and that radius was substituted into the original area formula, and it gave us the minimum area. After finding the minimum area, he was also interested into the height, so we substituted the value of R into the height to get us. We found the height by using the radius. Next question is a sector of a circle. So imagine, guys, this is a sector. A sector of a circle, radius r and perimeter is 20. If the perimeter is 20 and the radian angle is in radians, so you remember this is r theta. The perimeter is r plus r theta plus r. He said perimeter is 20. R plus r is 2r plus r theta. Wow, we got this answer. He's also talking about area of a sector, which is equals to half r squared theta. So can I find the maximum possible area? How can I do this? I can make theta as a subject and substitute it here. I think this is better to make theta as a subject from this expression. So 20 minus 2r is equals to r theta, and then I will send the radius to the other side. This gives me theta. Now this theta, I'm going to plug it here to get the area in terms of r. So half r squared and 20 minus 2r divided by r. Now this r is going to cancel with this one, and I'm getting a is equals to half r, and also from the top I took 2 common, so 10 minus r inside 2 cancelled. Can I open the brackets? It gives me 10r and minus r squared because they will be multiplied. Now to get the stationary values, dA over dr, it is 10 minus 2r, put it equals to 0. 10 minus 10 is equals to 2r, and radius is equals to 5. Once I get the value of the radius, I need to plug it into the, is he for asking maximum area? Yes, we need to plug it into the area formula, where we need to substitute it here. So area is equals to half. I think 2 was cancelled already. No need to write it. Just write r, which is, or why not? We can substitute it here. Here. Okay. So 10, 5 minus 5 squared. So 50 minus 25. So area comes to us 25 centimeters squared. And that's all with it. Next question, he's talking about a spherical balloon. So a spherical balloon, guys, it's like this. It has a radius r. So what is the volume of a sphere? The volume of a sphere is 4 over 3 pi r cubed. The rate is given. Which rate is given? Come on, check it out. The rate of the radius is given. Yani dr over dt is given. dr over dt is given, which is 0.4 centimeters per second. And from centimeter per second, this is also clear that he is talking about the radius versus time. So dr over dt is 0.4 centimeter per second. Guys, can I find the rate of increase of surface area? Wow, he's talking about rates of increase of surface area. So what is the surface area formula? Surface area, can I write A for it? And it is also available in MF19. 4 pi r squared is the surface area for the sphere. He is asking you rate of increase of surface area. Yani dA over dt is required by the examiner. So what you can find from here, you can find dA over dr, boys, which gives you 4 pi, and this is 2r, and it gives me 8 pi r. What is the radius given to me? 20. Substitute, yani r is 20 given to us. Substitute it here. So dA over dr, 8 pi, in the place of r, I'm putting 20. It gives us 160 pi. Wow. So dA over dr, dA over dr is 160 pi. Put it on the side. dr over dt is also found. Allow me to find dv over dr from here also. So dv over dr, 4 over 3 pi, which is 3r squared, 3 cancelled. So dv over dr is equals to 4 pi r squared. Substitute also here the radius. So dv over dr, 4 pi and 20 squared. It gives you what? 20 squared times 4. It gives you 1600 pi. So this is dv over dr. Maybe you guys are thinking, Mr. Romer, we don't know what to do in this question. It's expanding. No worries, no worries. Just highlight the things which you can easily find from the question. Okay, now as I want to find dA over dt, right? we need to split this into two fractions. So dA over, this is dt, and I write here dr. Unfortunately, I don't have dr over dt given to me. Is it given? Oh, this is given. So dA over dr is given. Check what are the things given. Radius increase is given, and so why I found volume, guys? Look, everything is given to me. Why I found volume? Or maybe I saw the spherical balloon, so I thought maybe he's going to ask us volume. So I'm just erasing it. This is an extra work. Wow, this is an extra work. So check it out. Both of the things are known to me. This is dA over dr, and this is dr over dt. It is already given to me. Substitute these values. This is 160 pi, and this is 0.4. Get your answers. 160 times 0.4. I got 64 pi centimeters squared per second. That is the area of surface area, rate of the surface area of a balloon we wanted to find. We got it. Now the next question, number 7, he's talking about a cube. Volume of a cube. Let me draw a cube in front of you. The characteristics of cube is all the sides have same dimension, length is widths are same. He's talking about volume. The volume cube rate is given to us, dV over dt. It is 12 centimeters cubed over second. And he is also talking about the surface area of a cube. So how many faces it has? Well, the front area is x squared, and it has 6 faces. So the surface area is 6x squared, and the volume is x cubed. I don't know whether it would be needed or not. So can I find from here, guys, dA over dx, which gives us 12x. Is the value of x given? Yes, the value of x is 7. Substitute it here, 12 times 7, which is 84. I found dA over dx is 84. Examiner is asking you rate of the surface area. Any dA over dt is required. I'm going to write dA over dt. It is dA over dx, and then dx over dt. Unfortunately, I don't have dx over dt. The guy has given me dv over dt. So how to get dx over dt? It's pretty simple, guys. Don't worry. I'm going to find from here, from the volume formula, dv over dx. So dv over dx is what? 3x squared. He gave us the x, which is 7. So 49 times 3. It gives us 100, and so dv over dx is 147. Now you will be surprised. Mr. Romer has dA over dx already there, which is 84, but I don't have dx over dt. Can I further split it? I hope you will agree with me. So I'm gonna split it further. Dx over dv and dv over dt. Wow. Now I have both of them. Right, guys? I have both of them. It is 84, and dx over dv, can I just reciprocate it? And dx over dv will be what? 1 over 147. And dv over dt, in the beginning, it was given 12. So write everything in the calculator and get your answer. 84 times 1 over 147 times 12. So we got 48/7. Centimeter squared, what are the units used? Centimeter squared over second. This is the thing for the rate of surface area is pound. Now we go to the past paper questions. The past paper question, this is the equation of a curve. We want to find the first derivative and the second derivative. And this question came in 2020 May, June. So let me copy the question again. Y is equals to 3x plus 1 minus 4. I think we need to apply the chain rule here. Okay, so first derivative, dy by dx, derivative of 3x is 3, derivative of 1 is 0, minus 4 as it is, half goes back. So 3x plus 1, half minus 1, further derivative of 3x plus 1 is 3, because we need to take this derivative. Now 2 cancels with 4, it gives you 2. So dy by dx, I got 3 minus 2. And this 2 is going to multiply with this 3. This 2 is going to multiply with this 3 and makes it 6. 6 and 3x plus 1 raised by minus 1/2. Since the examiner is required the second derivative from you also, I'm going to take a second derivative. The derivative of 3 is 0, minus 6 as it is, minus half goes back. Chain rule, we need to apply minus half minus 1 for the derivative of 3x plus 1, which is 3. I'm going to cancel 2 with the 6, it gives you 3. Now we have here minus, there's 3 and there's 3. So we combine them together, gives you 9 and 3x plus 1, and we can use calculator to know minus half minus 1 is minus 3/2. So this is my second derivative. Next thing is he's talking about stationary point. So stationary point tells you that we have to put the first derivative equals to 0. I'm going to put 3 minus 6, 3x plus 1 minus 1/2 equals to 0. Send the minus thing to the other side. So 3 is equals to 6, 3x plus 1 raised by minus 1/2. Change the negative power to the positive power. Cross multiply. Send the 3 to the other side. Take the square on both sides. 4 minus 1, so x is equals to 1. So x is equals to 1, the x coordinate, we found it. Is he asking the x coordinate? No, he's asking coordinates. We need to get the corresponding y coordinate, substitute this value of x into the original value of y, which is 3x plus 1. So 3x plus 1, then minus 4, and then he writes 3x plus 1, yani 3x plus 1 raised to the power 1/2. Simplify. 3 plus 1 minus 4, 4 is power 1/2. You can use calculator. I got y is equals to minus 4. So hence, what is the point I found it? I found 1 comma minus 4. Now we need to check the stationary and the nature of the stationary point. We need to plug it into the second derivative and check what the sign of second derivative comes to us. So d squared y over dx squared, 9. In the place of x, I put 1 plus 1 raised to power minus 3/2. So 9, 4 minus 3/2. So the answer will come to you 9/8. Let me check for you. 9, bracket open, 4, bracket close, power minus 3 over 2. It gives us 9 over 8. Since it is a positive answer, it means 1 minus 4 is a minimum point. Next question, past paper question. He says equation of a curve is given to you, y equals ax half minus 2x. The curve has a stationary value that has x coordinate 9. So x coordinate is 9 to us for the stationary point. Let's try to find the first derivative. A as it is, half goes back, half minus 1, and the derivative of minus 2 is minus 2x is minus 2. As per the rule, first the stationary point, we need to put dy by dx equal to 0, and he gave you the x coordinate 9. So plug it here, 9. So a over 2, 9 minus 1 over 2 minus 2 is equal to 0. Try to simplify. A over 2, 9 raised to the power minus 1 over 2 is equal to 2. Cross multiply a over 9 raised to the power 1 over 2 is 2 times 2 is 4. This gives you 3, 4. So a is equals to 12. So we wanted to find the value of a, which is 12. Plug it back. So hence a is 12. So 12 x raised to the power 1 over 2 minus 2x. The value of x is already given to you 9. Plug it back here into the equation because we want to find the y coordinate. 9 raised to the power 1 over 2 minus 2. This is 9. 12. This is 3 minus 18. 36 minus 18. So y is equals to 18. And this is the y coordinate of point P is required to find. Next past paper question. We want to find the minimum point for this. Let me copy the question. Y is equals to 9 over 4 x squared minus 12x plus 18. I'm finding the first derivative. 9 over 4 2x minus 12, put it equals to 0. So it gives you 9 over 2x is equals to 12. 9x is equals to 24, and x is equal to 24 over 9, and x is equals to 8 over 3. We want to find the coordinates. It means we need to find the value of y as well. Substitute it into the original equation of a curve. 9 over 4, 8 over 3, whole squared minus 12, 8 over 3 plus 18. Use calculator. 9 over 4, bracket open, 8 over 3, bracket close, squared, minus 12, fraction 8 over 3, plus 18, and it gives us 2. So we found the coordinates, 8 over 3 and 2, which was the minimum point. Now, let me do the C part. In the C part, he gave you the equation of a curve, 18 minus 3 over 8, x raised to the power 5 over 2. And he says x coordinate rate is how much? It's an increasing rate, so we need to write it positive. So what is the increasing rate? Dx over dt, guys, 2 units per second. This is given by the examiner. And he's asking you what? He's asking you the rate of y. In other words, he's asking you dy over dt. Wow. So let's try to find dy by dx from here. 18 is 0, minus 3 over 8, 5 over 2 goes back, 5 over 2 minus 1. So dy by dx minus 15 over 16, 3 over 2. Substitute the value of x, which is given to you 4. Check that. What is the answer coming to you? Minus 15 over 16 or raised to the power fraction 3 over 2. It gives us minus 15 over 2. This is dy by dx. I found it. The dy by dx is minus 15 over 2. Now I want to find dy over dt, which should be equals to dy, and here is dt, dx and dx. In dy by dx, we found minus 15 over 2, and dx over dt is given in the beginning, that is 2. Cancel them. Oh, it means y is decreasing. Y is decreasing by minus 15 units per second. And that's the answer of our question. Now, question number 4, which is, I think, related to stationary points and maximum minimum points. He says that there is a window which is made up of 2 parts, rectangle. It is made up of rectangle. This is the rectangle, guys. And there is a semicircle. So what are the things included in it? He says the perimeter of the window. Perimeter of the window. If I'm talking about perimeter of window, I need to move all the way around this window. This is how much? Perimeter is 2r, and plus h, then plus h, and this is half circumference. So 2 pi r is the full circumference divided by 2, and this is pi r, half circumference. Combine them, 2r, h plus h is 2h plus pi r. He said perimeter is 8 meters, 2r plus 2h plus pi r. He said express h in terms of r. We need to make h as a subject. So 8 minus 2r minus pi r is equals to 2h divided by 2. So this is the formula for this. Next is I want to find the area of the window. So area of window, I will try to find it here. Area, so length into width, 2r times h. This is the area of the window. A2 is pi r squared divided by 2. So both areas have to be added. 2rh plus pi r squared divided by 2. So guys, can I just change it to this form, because I think students might have a problem. I'm just gonna divide 2 here like this. Okay, and then I'm gonna plug it here. A is equals to 2r. In the place of h, I'm writing this expression. 8 minus 2r minus pi r whole divided by 2 and plus pi r squared divided by. Now 2 cancelled. Area is equals to r 8 minus 2r minus pi r plus pi r squared divided by 2. Now a 8r 2r squared minus pi r squared plus pi r squared divided by 2. I think after finding this, we can further simplify it. As you know, this is minus pi r squared and this is half pi r squared. It will come to me after simplification minus half pi r squared. And this is the result which I wanted to prove. Check, guys. This is the same result which examiner was demanding, and we got it. Now I'm sure he's going to ask us to take the stationary value of a. So I'm going to take the derivative, which is 8 minus 4r minus half pi and 2r, put it equals to 0, 2 cancelled. 8 minus 4r minus pi r is equal to 0. 8 is equals to 4r plus pi r. And then take the radius common, 4 plus pi, and then 8 over 4 plus pi is equals to r. Since he didn't mention to get the answer in exact value of r, try to get this answer in decimals. 8 over 4 plus pi gives us 1.12. Radius is equals to 1.12. Find the value of r. Third part is done. Now we need to find whether it is a maximum or minimum. So where is my first derivative? This is my first derivative. Take the second derivative of this. And I take the second derivative, it will give me minus 4 minus pi, which is a negative value. So negative tells you that you are going to get a maximum area. That's all with this question, boys. Now, question number 5, rates of change. We gave you dy by dx already. And the point is given. He's talking about equation of a normal. So you remember dy by dx is a gradient of a tangent. It is a gradient of a tangent. Substitute the value of x here. 6 over square root of 4, 3 minus 3, 6 over 12 minus 3, 6 over 9, 6 over 3, which is 2. So your gradient of a tangent is 2. Gradient of a normal will be minus 1 over 2. I want to find the equation of a normal line. Y is equals to normal plus c. 0.3 minus 1 over 2. X coordinate is 3 given to us, point P. So 3 plus 3 over 2 is equal to C will give you 9 over 2. I'm going to get Y equals minus 1 over 2x plus 9 over 2. Since the examiner is asking you to get the form like this, I'm going to multiply with 2. So it helps me to write the answer. 2 to cancel, minus x plus 9, send it to the left. So x plus 2y is equals to 9. That's the final answer for this question. Now, question number 6. The examiner give you this type of a function. For sure, you will say, if we want to get the derivative, we need to send this to the top. Y is equals to 6, 5 minus 2x raised to the power minus 1. A gradient, the word gradient, it means dy by dx has to be found. 6 minus 1 goes back. 5 minus 2x minus 1, chain rule. The further derivative of 2 minus 5 minus 2x is minus 2. So gradient, this is minus 6 and this is minus 2. We'll make it after taking the multiplication 12. So 5 minus 2x raised to a minus 2. What is the value of x given to us? Put here x is equals to 1, m is equals to 12. So we got m gradient m4 over 3. Next question, rate of change. Examiner says that the rate of y, yani dy over dt, it is given to you 0.02 units per second, is asking you rate of x, yani dx over dt is required. So if I want dx over dt, that should be equal to dx times, here is dt and write dy. Guys, dx over dv is dy, we have found it, which came to us 4 over 9. This is dy by dx. This is dy by dx, but I need to find dx over dy, reciprocate it. Three over 4 and dy by dt, we can use 0.02. The units per second. Right? Now we got the question number 7. He says volume, it is equals to 243 minus 1 over 3, 9 minus x raised by 3. He talks about water is pumped out at the rate of 3.6 meter cube per hour, yani the rate of the volume is given to us. Pumping out dv by dt, it is equals to is pumping into or pumping out? Pumping into. Yeah, that's why the rate will be positive. 3.6 meter cube per hour. Good. I'm gonna find from here dv over dx, 243 derivative 0, minus 1 over 3. Chain rule, 3 goes back. 9 minus x squared. Further derivative of 9 minus x will be minus 1. 3 cancelled. Now this minus 1 will make it as 1. 9 minus x whole squared. Substitute the value of x. This is depth. X is equals to 4. I got dv by dx 25. Now I want to find the depth of the water, any dx over dt. I want to find dx over dt. Can I split dx over dt into 2 fractions? Dx dt, this is dv, this is dv. Reciprocate it. And dv by dt is 3.6. 3.6 divided by 25 gives us 0.144 centimeters per second, or meters per second. I'm done, guys. So as you see, I have completed the differentiation, further differentiation with you. The whole of the revision pack has been covered in our videos. Now this is your duty to watch it and solve it with your hands. Thank you. Assalamu alaikum wa rahmatullahi wa barakatuh.